Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. So, as promised, this is the second video regarding the solution of the specimen paper of the physics subject of class 10 ICC board term 1 examinations. Okay, so as discussed in the previous class, I have discussed up to question number 1 subpart D. Today we will be discussing the next questions that are in your sample paper. So let us quickly move on without wasting time. So let us now move on to the next question, question number 1 subpart E. Okay. If you have any doubt or query regarding the questions, please do write in the comment box so that we can answer your queries. Okay, so let us quickly move on to the question number 1e. What does the question number 1e says? Okay, here it is given that the wavelength of a light in a medium A is 600 nanometer, isn't it? Now the wave enters a medium B of refractive index 1.5. Now the question has been asked, what are the required steps to find the wavelength of the light in the medium B? Okay, so fine. So what are the, first of all, when you are solving any problem in physics, it is very important to note down the given facts, the given data. So quickly just let us note down the given data. So here we are solving question number 1 subpart E. It has been given that the wavelength of the light in medium A is 600 nanometer. Okay, fine. The refractive index of the medium B, has been given as 1.5. Now what you have to find out? You have to find out the wavelength of the medium B. So this is what we need to find out, isn't it? Okay, so this is our required. So what are the steps that you need to do? So let us quickly see some formulas regarding the solution of this problem. What are the formulas? So let us see. Now see, you know that refractive index. Okay, so there are two kinds of refractive index. One is the absolute refractive index and one is the relative refractive index. So coming to the fact, what is absolute refractive index? As I have promised that I will be discussing brief theories regarding the questions. So in that context, I am discussing about the relative refractive index and absolute refractive index. So what do you mean by this term absolute refractive index? Absolute refractive index, or I can regard it as absolute RI. Now see, absolute refractive index mu is defined as the speed of light in air to the speed of light in that medium. So absolute refractive index of any medium, okay, how it can be defined? It can be defined as the speed of light in air, or you can say rather vacuum, by speed of light in that medium. So this is the definition of absolute refractive index. Okay, so now see, speed of light in air, it's regarded as, or it is denoted by the letter C. So I can simply write it as C by the speed of light in that medium V. So this is the absolute refractive index. Fine. Now as you know that light travels with the greatest speed in vacuum. In any other medium, when it travels at a lower speed. So definitely absolute refractive index, value of absolute refractive index of any medium has to be greater than 1. So remember this point, the absolute refractive index of any medium is always greater than 1. Okay, so I think it is clear to you all now. Absolute refractive index, fine. Now there is another term called relative refractive index. What is that term? If you have not noted down the formula, if you want, you can pause the video and note down the formula. I am just rubbing it off. I am moving on to the next topic, there is relative refractive index. So what is relative refractive index? Now let us quickly move on to the next point, relative refractive index. So let us see what is that relative refractive index. Okay, so I think we have noted down the formula as relative refractive index. So relative refractive index, relative refractive index, relative refractive index or relative RI. Okay, so this relative refractive index, what we do, we actually determine or say the refractive index of any medium with respect to another medium. And when we are saying with respect to another medium, that can be any medium. Okay, so relative refractive index, and when that reference medium is here, that turns out to be the absolute refractive index. So relative refractive index, say a light, as given in the question, the light travels from the medium A to medium B. Okay, so medium A to medium B. When light is traveling from, as given in the question, when light is traveling from medium A to B, when light is traveling from medium A to B, now the refractive index given here, this refractive index is actually the refractive index of medium B with respect to A. So we write it in this fashion and we say refractive index of medium B with respect to medium A. Now this turns out to be absolute refractive index of medium B to the absolute refractive index of medium A. So this is the formula, absolute refractive index of medium B to the absolute refractive index of medium A. Now so this is the relative refractive index. I think it is clear, relative refractive index. Okay, so now you see what we are doing here. The relative refractive index, see, can be, now the absolute refractive index can be written as, so I can write it this way, C, this equals to C by VB by C by VA, isn't it? Speed of light in vacuum, VB is the speed of light in medium B and VA is the speed of light in medium A. So I think I can clearly simplify this formula as what we can do, we can write it as VA by VB. We can write it like this way. Okay, fine. Now you know there is another formula that we can use. You know that the speed of light in any medium can be given as the product of the frequency and wavelength. Okay, so I can also write the speed of light, I can write it as C equals to F lambda. Now when the light is traveling in vacuum, the formula is C equals to F lambda. If the light travels in any other medium, then it will be V equals to F into lambda for that particular medium. So this is the first formula, is when the light is traveling in vacuum or air. So this is in vacuum or air, okay, vacuum or air, fine. And the second formula, this is true for actually any other medium, okay, any medium, fine, any medium. Okay, so this is the formula. Now using this formula we can say that what you can say, let us quickly see. So if we utilize this formula V equals to F lambda and put it here, so what will be the equation? Now I think we have noted down the formula, so I am just rubbing it off the board. Okay, so I can write, now simplifying, I can write, so what I can write it as like this: mu B with respect to A equals to V A by VB. So this will be termed as F into lambda A by F into lambda B. Now why I have written the F same? As I have discussed in the previous class, the frequency of light does not change when it passes from one medium to another medium. So definitely the frequency will remain same. Now this value has been given as 1.5, as you can see from the given information. So this is 1.5. The F is being cancelled out. Now lambda A turns out to be 600 nanometer by, I have to find out the lambda B. So regarding this, what we can write, or lambda B equals to 600 by 1.5. This turns out to be, so how can I write it? So 600, if I just take the point out from here, I can write multiply 10 here, and the value is 15. So 15 4s are 60, I get 1 0 here. So it actually turns out to be 400 nanometer. It actually turns out to be 400, and the unit is nanometer. Okay, as the wavelength of the medium A has been given in nanometer, so after calculation I can say that the answer will be in nanometer. So refractive index of wavelength of the medium B, of the light in medium B, is 400 nanometer. Now come to the question. So what has the question been asked? Let us see what has the question been asked. The question has been said, let us see the question. Okay, we need to, the question as has been asked, it has been asked to find out the steps to determine the wavelength of the medium B. So definitely now we can determine what steps are required. First we need to write out the formula 1.5 equals to 600 by lambda B. So it is the step number 2. Okay, and from that step number 2 we can get the lambda as 400 nanometers. So step number 2 and step number 3 is enough for us to determine the wavelength of the medium B. So our answer will be, what will be our answer? Our answer will be question number 1E. Question number 1E is turns out to be, so question number 1E, this answer turns out to be, 1E turns out to be option 2. So this is option 2. So I think the answer is clear. The theory regarded to this question is also, I think, very clear to you all by now. Okay, so quickly we will be moving on to the next question. So let us see what is the next question. Okay, so the next question turns out to be like this. Okay, there is again a diagram has been given. A diagram shows a image formed at a distance of 36 cm from the lens, okay, of focal length 12 cm. Now the lens has not been mentioned of which type. Okay, so let us see what has been asked. So distance, image forms an image at a distance of 36 cm from the lens. So image distance has been given, focal length has been given. Okay, so what has been said, let us see. The image has been given, say the image formed has been here a inverted image. So definitely it's a real and inverted image. Inverted means it is definitely a real image. Now real images are always formed by convex lens. Now concave lens does not form a real image. Okay, so regarding this lens, I will just briefly discuss about this topic lens, just and mention the formulas that are required to solve the problem. Let us see. Okay, so let us quickly come on to the next question. So we are discussing question number 1F. Okay, 1F. So the next question comes out 1F. Okay, I will have the option here and I will discuss 1F. Okay, so I am discussing question number 1F. Fine, 1F. Okay. Okay. So regarding this, there are 4 questions regarding the 1F. Okay, fine, 4 questions regarding 1F. So first let me tell you that there are 2 kinds of lens. Okay, we can also say spherical lens because the lenses are being formed from or using spherical glass balls. Okay, so lens are of 2 types. What are the types? The 2 types are, one is concave and another one is convex. If you can remember the diagram, concave is somewhat like this and convex is somewhat like this. So concave lens is generally the one which has its edges bulging out, okay, or edges are thicker rather than the middle portion. The middle portion is thinner, whereas the convex lens, the middle portion is bulging out, the middle portion is thick, fat, and the outer edges are thinner. So these are the two types of lens. Now if I briefly come to the sign conventions regarding the length, so let us briefly talk about the sign conventions regarding the lens. Okay, so I think this has been a problem to many of us, the sign conventions. What are the sign conventions? Let us just briefly have a review. Okay, so we are just taking about the sign conventions. Okay, sign conventions regarding the lens. What are the sign conventions? See, now there are 2 to 3 parameters that we need to think of. One is the object distance, another is the image distance, focal length, and object height and image height. So these are the 5 things that I need to consider, and there is a definite rule for determining the sign of these parameters. Okay, so now first of all coming to the convex lens. Convex lens. So what will be the sign for the convex lens? Okay, let us see. Now see, for convex lens, if I just draw a convex lens, okay, this is a convex lens, and the principal axis will be passing through its middle. This is a convex lens. If I keep an object on the left side of the lens like this, whatever its position may be, the incident light ray actually goes in this direction. The incident light ray goes in this direction, isn't it? Okay. Now this is the optical center of the lens. Fine. Now regarding the sign convention, whatever is above the principal axis, is taken to be as positive. Whatever is below the principal axis is taken to as negative. Okay, so whatever above the principal axis, okay, fine. So then you can easily understand that the object height that we are talking about. So object height, taken as O is positive. It is positive. Okay, fine. The object distance. What about the object distance? Now see, when you are measuring the object distance, definitely you will have to move from this point, this optical center, to this direction in order to measure the object distance. So you are going against the direction of the incident ray. When you are going against the direction of the incident ray for measuring any length, then that length is considered to be negative. Okay, so here the object distance, denoted by the letter U turns out to be negative. Okay, fine. Then if you consider the focal length, okay, as you know, the convex lens, for a convex lens, if light travels parallel to the principal axis, okay, they will definitely meet on this point. So here somewhere lies the focus. Okay, now if you want to measure the focus, you have to go in this direction, that is in the direction of the incident ray. So when you are going in the direction of the incident ray, then that distance is taken to be as positive. So again, focal length denoted by the letter F is positive. Okay, is positive. So object height, object distance, and focal length are all positive. Okay, fine. And when you are talking of the concave lens, now just let us come on to the concave lens. So what regarding the concave lens? Now the concave lens, okay, for concave lens we can just draw the figure here. Concave lens turns out to be like this. Okay, This is the principal axis. This is the principal axis. Okay. This is the object. Now the light ray goes in this direction like this. Okay. So then it gets refracted like this. It gets deviated. You know. So its focus lies somewhere at this point. Okay. Fine. Now this is the optical center. This is the optical center of the lens. Now when you are talking of the object height for a concave lens, again here also the object height turns out to be positive, isn't it? Here also the object height turns out to be positive, isn't it? As because the object is always above the principal axis, definitely the object height will be positive for concave lens also. Okay. Now when we are talking of the object distance, again the object distance is against the, when you are measuring the object distance, it is against the direction of the incident ray. So definitely this is also negative. So this is also taken as negative. Okay. And what regarding the focus or the focal length? Now here the focal length turns out to be negative as you are going in the direction against the incident ray for measuring the focal length. So focal length turns out here to be negative. So these are the signs that are to be taken for object height, object distance and focal length for concave and convex mirror. Okay. So is it okay? Fine. Okay. So now if I talk, there are given two parameters. One is the image distance and one is the image height. What are the sign for this image distance and image height? Now quickly moving on. If you have not noted it down, please note it down. Okay. Now see the image distance and the image height. Okay. So the image distance, image height. This is regarded as I will be taken as positive if the image is virtual. Virtual image are always erect. So if the image is virtual erect, image height is taken to as positive, and it is taken to as negative if the image height is real and inverted, then it is taken to be as negative. Okay. So I think it is clear. Image height positive and negative. Okay. Now likewise, real images are always found on the right side of the lens. Real images are always found on the right side of the lens, and real images are always found by convex lens. Remember this one thing. Real images are always found by convex lens. Okay. So image distance denoted by the letter V, okay, will be positive for which image? Real image. So it is positive for real image. Okay. So real image. Okay. And the image distance is taken to be as negative if I consider it to be a virtual image, as because virtual images are always found on the left side of the lens, left side. Okay. Fine. So we will be stopping our discussion here. The next topic, the next discussion regarding the problem, we will be continuing it on the next class, as because time is not permitting our lecture. So till then, take care. Thank you. Tada, bye bye.